Hey guys, all right, let's go ahead and talk about finding the derivative of an inverse function. So we're going to go ahead and use the rule that for finding the derivative of an inverse, we do dy dx is equal to 1 over f prime of y. You can take the derivative and reciprocate it, or you can do it implicitly by making this y equals x to the third plus x squared plus x plus 1. Switch your y's and your x's and derive implicitly. So from class, you'll remember that we ended up with this derivative, 1 over 3y squared plus 2y plus 1. The confusion was, should we plug in 4 or not? Well, let me explain, now that I've gathered my thoughts together, what you're doing. G prime of 4. Okay, G represents the inverse of f. Therefore, this is an x, but in inverse world. So in inverse function world, 4 is the x value. But if you take a look here, they didn't ask us for an x value. We need to plug in a y value. So 4 is an x value in inverse world, all right? We need to find g prime of 4, but we need to plug in a y value. So who is 4's y value? How do we figure that out? That's the job. Because even though we're looking for g prime of 4, we don't have anywhere to put 4. There's nowhere to put him. He's an x. In inverse world, he's an x. And this is the derivative of the inverse. So when I go to plug the x value of 4 in, I'm like, I got nowhere to put him. Okay? So who should we be plugging in? Let's figure that out now. So let's recap. I have my derivative. I'm looking for g prime of 4. 4 is x in the inverse world. So who is y? Well, I don't have an inverse function. They never gave me one. They gave me a regular function. And if I wanted to find the inverse function, if I wanted to go back and find the inverse function, it would be a hot mess. So we have to work backwards to figure this out. 4 is x in inverse world, therefore 4 is y in function world, because they're inverses of each other. So let's recap this, because I just want to say, like, we're doing this because I don't have an inverse function to throw 4 into to find who his partner is. I don't have an inverse function, but I do have a regular function. If 4 is x in the inverse world, then 4 is y in regular world. So I take f of x, which is equal to x to the third plus x squared plus x plus 1, and I set it equal to 4. Okay? Right? And since, again, 4 is x in the inverse world, that means 4 is y in f of x world, so I set f of x equal to 4 so that I can find who x is. When I do that, and I think for just a second, 1 plus 1 plus 1 plus 1, okay, if you solve, x has got to be 1. So let's chew this back down. Let's size it back down. All right, let me mark this off for you. Here we go. We're looking for g prime of 4. G represents the inverse function. 4 is an x value in inverse world. Therefore, 4 is a y value in function world. I am looking for who is y in inverse world. Why do I care about that? Well, because I need it right here. I need to put it. I can't find g prime of 4 using 4 because the derivative is in terms of y. And 4 is an x value in inverse world. Who is y? Who is he? That's what we're trying to figure out. Well, 4, this guy, is y in function world. And we just found out that 1 is x in f of x world. So in f of x world, our ordered pair is 1, 4. And in in inverse world, our ordered pair is 4, 1. All right, how did I do that? I solved this equation right here. 4 equals x to the third plus x squared plus x plus 1. And I solved that and found that the only way that that could make 4 is if x was 1. That means in function world, the ordered pair is 1, 4. So in inverse world, when x is 4, y is 1, that gives me a number to put right there, which is why the answer is 1/6. Let's try another one. All right, here's number 34. Let f be a differentiable function such that all these rules apply. The function g is differentiable and g of x is the inverse of f. What is the value of g prime of -4? Okay, g prime of -4. This is x in inverse world. All right? If it's x in inverse world, who is y? Who is y? All right? -4 is x in inverse world. Who is y? So where is f of x equal to -4? Really, because we don't have anything about the inverse function. All we know is everything about the regular function. Everything that we know is about the regular function. So if it's x in inverse world, then he is y in function world. -4 is x in inverse world, therefore he is y in function world. When f of x is equal to -4, if we go back to what they gave us, f of x is equal to -4 when x is 9. So who is y? Well, y is 9. Let's try that again. We're looking for g prime of -4. Okay? G prime of -4. X in inverse world is -4. His partner is 9. Why? Well, because in regular function world, when f of x is -4, y is 9. So g prime of -4 is going to be equal to 1 over f prime of 9. Let's try that again. G prime of -4 is going to be equal to 1 over f prime of 9. Remember, dy dx. For inverses, the rule is dy dx is equal to 1 over f prime of y. Okay, f prime of 9. Who is y? When x is -4 in inverse world, y is 9. So the derivative of the inverse at -4 is 1 over f prime of 9, or 1/3. I hope that's gelling for you. Let's try another one. All right, so this is the next problem. So g inverse is the inverse function of g. What is the equation for the line tangent to the graph of the inverse at x equals 4? So we need the derivative. We need the g inverse of x. We need the derivative of that guy at 4. Let me change that to 4. Oh, at 4. Okay, so again, 4 is x in inverse world. Therefore, he is y in function world. Y in function world. So right there. Okay, so g of -2 is equal to 4. Therefore, g inverse of 4 is equal to -2. Why does that matter? Well, because the derivative of the inverse at 4 is equal to 1 over g prime of y, also known as 1 over g prime of 2, nope, -2, also known as 1 over 2 as our slope of the tangent line. So again, we were looking for the derivative of the inverse at 4, starting here. That's x in inverse world. So g inverse of 4 is, we didn't know this, is what? Well, we don't have an inverse function, so we have to use the regular function to work backwards. So if this is x, oh, sorry about that. If this is x in inverse world, then he is y in regular g function world. So g of what is 4? G of negative 2, we can find it right here, is 4. So g inverse at 4 is negative 2. You can fill that in. And why do we care about that? Because that is what we're evaluating in the denominator when we take the derivative of the inverse. The derivative of the inverse is 1 over g prime of y, not 1 over g prime of x, 1 over g prime of y. So I needed to find who 4's partner was. So it's 1 over g prime of negative 2. And g prime of negative 2 is 2. And that's the slope of the tangent line. And we're looking for it at x equals 4. So our point is 4 comma negative 3. We found that right here. Point, slope, and now we can write the equation of the line. All right, here's the last one I'm going to do for you guys today, which is like what? I only skipped like one of them. Anyway, if y equals cosecant inverse of x squared, which of the following represents dy dx? Notice how we're looking for dy dx, so we're not going to be using our cosecant inverse formula, because if you take a look at all the answer choices, it's in terms of x and y, okay? And I actually sat with this one for a little while and I was like, all right, well, how would I switch the y's and the x's here, because it's locked with this cosecant? You know, the tactic is switch y and x and derive implicitly. But I can't really switch y and x here because this cosecant inverse. But here's what I can do. If I multiply by cosecant on both sides, cosecant inverse of x squared, okay? I multiplied both sides by cosecant. So I've got cosecant y is equal to cosecant times cosecant inverse of x squared. A function and his inverse unravel each other. And there we have that. Cosecant y is equal to x squared, which we can most certainly find dy dx now. Okay? We can most certainly find dy dx and have our result be in terms of y and x with like trig, you know, not d dx. So we're going to go ahead and derive both sides now. All right, so I went ahead and took the derivative of cosecant y, which is cosecant y cotan y dy dx, starting to build my dy dx here. That's equal to 2x, which is the derivative of x squared. Notice how these two are gone now. Simplifying cosecant cotan y, because I'm trying to build one of these answers, also trying to isolate dy dx. Simplifying here, this is 1 over sine, and this is cosine over sine, so it's cosine y over sine squared y times dy dx. Multiply both sides by the reciprocal. Oh, wait, time out. Derivative is negative. Sorry. There we go. The derivative of cosecant y is negative, cosecant y cotan y. Hopefully you caught that. So let's multiply both sides by the reciprocal to get dy dx by itself. So that's going to equal us with negative 2x multiplied to sine squared y over cosine y. And dy dx is equal to that. You can see the answer starting to form there, which is negative 2x times sine over cosine times sine. There's my sine squared y and my cosine. And there's my answer, negative 2x sine y right there and tangent of y. Okay, I hope you understand now. Thanks, guys.